Hello, everyone, and welcome to our Summer 2020 webinar series. My name is Jim Shaw, and I'm the Director of Sales and Marketing at DTS, and will serve as your moderator today. Thank you for joining us as we continue our effort to inform and educate our customers and partners on various data acquisition technologies as they apply to solving real-world applications. Today's event is focused on SWaP-C data acquisition solutions for flight testing, where you will learn more about our miniature, rugged data acquisition systems for aerospace and defense. Before I get started, I'd like to cover the format and a few logistics. The webinar will be a slide presentation in audio from the presenter only. All attendees will be muted, but please make sure to check that the slides are visible and that you can hear the presenter clearly. We encourage you throughout the presentation to submit questions by typing them in the Q&A window. You'll see the button at the bottom of the screen. We have a panel of experts monitoring and answering questions throughout the webinar, and we'll also scan the questions at the conclusion and answer as many as we can, time permitting. At the end, we will compile all questions and answers and send them out to everyone in a follow-up email. The session is also being recorded and will be available on our website shortly after. If there's a specific topic that you'd like to cover directly in more of a private setting, please reach out to us and we'll coordinate with our sales and engineering teams and set something up with you. Today's presenter is Wei Nguyen. Wei is our aerospace and defense sales manager and serves as our product manager for our SLICE6 AIR product line. Also with us is Mike Beckage. Mike is our co-founder and CTO, and he runs our worldwide support organization. And Locke Pham. Locke is a manager of our firmware engineering, and he is responsible for our Chapter 10 streaming implementation on SLICE6 AIR, which you'll learn more about in the presentation. So with that, I will turn it over to Wei.
All right. Thanks again, Jim. And really, thank you, everyone, for taking time out today to participate in our webinar. We hope you'll find the information useful and informative. Before we dive into the details, I wanted to give you a brief overview of DTS and our company. DTS was founded in 1990, and we have our main operations and headquarters based out of Seal Beach, California. Our Novi, Michigan office is responsible for service support, specifically for our automotive and crash safety customers. In addition to the domestic offices, we also have a network of remote service and support locations worldwide. Locations in the UK, France, China, Korea, Japan, and Bali allows our technical support team to really have 24/7, 365 coverage. And essentially, it's to meet the fast response expectations demanded from our customer base. Currently, we have a staff of 108 team members. Our market is really separated into three distinct categories. We have aerospace and defense. So these customers include, organizations such as U.S. Army, the Navy, the Air Force. We also support a number of government labs, DOE labs of various industry and focuses. And we also supply to major defense contractors and suppliers as well. The bread and butter of DTS and the market that this company was founded on was automotive crash safety. And so that still represents a significant portion of our business. Some of our customers include both domestic and international OEMs, tier 1 and 2 suppliers, and a number of government and private crash safety labs and related automotive safety and human injury research. And then finally, our research, commercial, and industrial business kind of rounds out the rest of the DTS products. So some of these names kind of represent just a fraction of our customer base, but hopefully it allows you to see the breadth of the company reach. At DTS, we specialize in engineering and manufacturing of test and measurement solutions. And we have three primary product categories. Data acquisition systems represent a good 80% of the DTS sales. Our data acquisition systems are configurable, they're scalable, and you can build up a test setup from as low as 3 channels, all the way up to thousands of channels. Our data loggers essentially are standalone, complete autonomous recorders. They have embedded sensors, and they can be programmed to operate autonomously, at up to months or years at a time, and wake up only when an event is detected. And finally, our sensor lines. And more specifically, we have angular rate sensors and that are pretty much designed for dynamic measurements or dynamic events. And so these three product lines are really what we focus on and what we specialize in. Some of the differentiators and what makes us unique from other test and measurement manufacturers can be attributed to these kind of three unique capabilities. Number one, our products are all ultra miniature. So we continue to be the world leader in cutting edge miniature data acquisition systems. For instance, our SLICE micro system, which was introduced over 13 years ago, still continues to be the leading, miniature configurable data acquisition system of its type. The product is also shock hardened and rugged. So we have products and applications where these systems are seeing acceleration and shock pulses up to and beyond 60,000 Gs. And finally, standalone operation. We have onboard processor that allows the data acquisition unit to operate without connection to the PC. So these three differentiators has really enabled a number of customers to rely on our products for their demanding and challenging applications. The product's small form factor, rugged build, and autonomous operation has been used for tests such as UAVs. So typically launch measurements, flight measurements, and impact measurements are all relying on our miniature technologies. Ordnance, launch and impact. So our systems and our onboard recorders have been used to capture extremely high launch forces and also impact hard target recording as well. Aircraft stores such as ISR pods and weapons. So captive carry applications where customers want to measure environmental parameters on the test article during flight. The ability to install and run a test without being connected to a dedicated instrumentation system is really an attractive feature for these customers and users. And finally, eVTOL. So the whole rotary wing and compact UASs have really been a good opportunity and area for our technologies. And so our involvement in the aerospace and defense markets really gave us a visibility into the future test needs. So new platforms and advancements in UAV and UAS technologies and weapons and missile technologies, the advent of fleet modernization programs and commercial launch, all areas where we're seeing increased activities. And with these new platforms comes also new and more demanding requirements. What we're seeing now is a strong emphasis on SWaP optimization. So reduce size, weight, and power are all key drivers. Emphasis on cost, and more specifically cost reduction, and shortened or aggressive development timelines. So the ability to bring a product from R&D to market is something that drives a lot of these new programs. And as such, the DTS saw an opportunity for our technologies to address these new challenges. For almost everyone in flight test, integrating a platform starts with assembling a data acquisition unit or a data acquisition system. The process involves combining discrete modules or cards with distinct functions into a single chassis. So you usually start off with a power card, communication card, and then you add on your timing and your bus data. And then there's a variety of analog cards as well. So one for differential signals, single-ended signals, strain, etc. These cards are combined into a single chassis or a rack. And so the combination of these components really increases the mass and the weight. And then in addition to that, the central placement of the dial requires sensor cabling be routed throughout the aircraft. And so the overall result really is a large and costly and also time consuming. So by leveraging our experience in rugged and miniaturization of data acquisition, we sought out to combine what was once disparate components and introduce a new and unique approach to flight test instrumentation, and more specifically, data acquisition. SLICE6 AIR represents really our first entry into the flight test community. This all-in-one solution is an Ethernet-based data acquisition unit. Each module has 6 channels of universal sensor support. Every module contains an internal microprocessor, an FPGA, and a 2-port Ethernet switch. We also have 16 gigs of non-volatile flash. And the system can be configured to operate in 3 separate and unique modes. First is recording in place. You can set the unit up as a data recorder. Each of the 6 channels has a maximum sample rate of 400,000 samples per second. For real-time streaming, each of the 6 channels can also stream out at 20K samples per second. And coming later this year, we'll be introducing a dual record and stream capability. And because the unit was designed to be autonomous and standalone, the unit also has an internal real-time clock, so no need for an external time source. We've also simplified and miniaturized data acquisition system with this enclosure. The product itself is a 42 millimeter by 51.7 millimeter footprint. It can be mounted with 4 through-hole mounts. There's 2 LED indicators, one for system status, one for power. And then finally, there's 2 connectors, one for the sensors and the other for system. And because we understand the target market, the target application for this product is going to be flight testing and various other kind of extreme environmental testing, we've also qualified the unit to meet MIL standard 810G and 461G. So really the product has been designed to support applications in harsh and extreme environments. It can operate in temperatures as low as -40 to +80. It's been shock rated to 500 Gs. And again, MIL standard 810 qualification for high and low temperature, vibration, shock, humidity, and altitude. MIL standard 461 certification has also been approved for EMI, so both radiated and conducted emissions, as well as radiated and conducted susceptibility. So taking a look at the sensor connector, we use a 51-pin MDM or micro D connector. There's 8 pins dedicated to each channel. And so each channel you can selectively choose between a bridge or piezo resistive sensor or an IEPE sensor. Each channel also supports sensor ID. The sensor interface provides 5-volt excitation, 20 milliamp source to a bridge and piezo resistive sensors. And for our IEPE or ICP sensors, we supply a 24-volt, 5 milliamp constant current. Input range for bridge is 0 to 5 or plus and minus 2.5 with a 2.5 volt center. Input range for IEPE sensors or 0.5 to 23.5 volts. The system also has programmable and adjustable gains. So we can go as high as to 1280. Bandwidth is up to 50 kilohertz. We've also added an adjustable 5-pole Butterworth filter up to 40 kilohertz. And each of the 6 channel has its own individual 16-bit ADC. Sample to sample accuracy is less than 10 microseconds via 1588 time source. This is a top-level view of the sensor signal chain. I'm going to point out some key features of this implementation. So we've got individual excitation source per channel. Again, 5-volt, 20 milliamp for bridge or PRs. We also have a dedicated IEPE 5 milliamp constant current, 24-volt source. There's protection from ESD, EMI, and RFI. The input can support both differential and single-ended inputs, and we also support half-bridge completion. We have programmable gains in a summing amp, and this is our 5-pole Butterworth filter flanked by 2-pole fixed. So this configuration and this layout really allows customers to hook up a variety of sensors. And of course, reaching out to our technical support team and our application folks, we'd be more than happy to discuss your sensor hookups and requirements as well. Taking a look at the sensors or the system connector, you see that we use a 25-socket MDM. You've got dedicated pins for both power and ground. Connection for Ethernet to each of the 2 ports. There's hard connections for what we call our onboard recording functions. So start record, on signals, status, and event. And then we also have support for your serial inputs. So your IRIG-B time source, your NMEA GPS input, and PPS. Our system interface can support power from 9 to 36 volts DC. Each of the module has a lower than 3-watt power consumption. Again, communication is with an internal Ethernet. It's a 10-base-100 2-port Ethernet switch, transformerless Ethernet switch. That's how we were able to get the unit down so small. Our streaming is via UDP Ethernet. And of course, it's in either IRIG 106 Chapter 10 or TmNS formats. Time synchronization can be handled via 1588, so timing over Ethernet. We also support, of course, native or legacy IRIG-B and GPS, so using NMEA data and PPS signals. For onboard recording controls, you have access, again, to remotely turn on and off the system. There's provisions for status LEDs, ways to start record, as well as input in a event or TTL or T0 signal. So we really designed this product to be interoperable with existing products, or specifically existing flight test products in the market there. And as such, we've support two of the kinds of adopted standards here: IRIG 106 Chapter 10 and IRIG 106 Chapter 21 28, or commonly known as TmNS. So for Chapter 10, we can format the data in either an analog or PCM format. We support both time formats 1 or 2, and the system generates a CGDP or TMATs, TDP, and data packets as well in the payload. For TmNS, currently we can do and support PCM or SuperCom, or we can just send TmNS data packets only. Of course, this is by no means the only formats that we currently support. This is just what has been identified so far. So we're more than happy to hear your requirements as well. So the fact that we're streaming out in these common standardized format allows the products to be used in a number of ways. For instance, you can hook it up directly to an encoder or transmitter for TM applications. If there's an existing serial infrastructure and you want to connect the system as an adjunct, you can use various network switches or gateways. And finally, our data can be streamed just directly to a Chapter 10 recorder. For COTS connector options, we'll offer a number for a couple of different options for the sensor and for the system. So for looking at the sensor, we will be offering just bare connectors. So 51 socket MDM. These are all solder cups. These are just bare connector assemblies. So both the 51 socket MDM is available, as well as the 25 pin MDM as well. And DTS will be manufacturing custom back shells. So we'll have variants on this as well. So a 51 pin MDM with our back shell, or a 25 pin with our back shell. This helps with strain relief and cable routing. The system side is a little bit unique in the sense that we'll be also offering a custom PCB with solder landing pads. So instead of having to wire leads to solder cups, it's going to be much easier to do that with the PCB. And the reason being is because there's if you're chaining multiple modules, both the power and the Ethernet lines would need to be bused. And so it's going to be a lot more difficult to try and cram 2 or 3 wires into a single solder cup than it would be to just use your solder pads. So now that you have a better understanding of SLICE6 AIR, setting up a standalone data acquisition system is really as easy as connecting analog sensors via the 51 socket connector, and then supplying power, Ethernet, and a time source. And so with that, you have a complete standalone, fully autonomous data acquisition system. Now, if 6 channels is not enough, of course, you can daisy chain modules to one another. The next few slides, I'm really going to just show some examples of applications that we're supporting. The first one is a standalone application. This one was designed to be act as a data logger, essentially, so record to memory, a captive carry application. The customer has a test article. They have limited space, and the ability to daisy chain modules allowed the customer to kind of put our SLICE6 AIR modules into, wherever space allows. And so connection to the DataPro software and configuration is all programmed via the interface device. Once that has been saved, the customer and the user can disconnect the interface device, and the system can sit on the shelf for as long as they like. And the next time that the system is booted up, it's now operating off an internal battery and waiting for some type of start record signal. Of course, once that test is completed, you would reconnect the interface device and download the data for viewing after the fact. A slight variation on this is a TM application. So instead of recording in place, the customer now wants the ability to stream or TM that data down to ground. So there's products out there in the market. I'm just referencing this Quisonics product that would take our Ethernet data stream and convert that and encode that into a transmitter and send that information and data stream down for visualization with a Chapter 10 or TmNS display. So again, there's numerous ways to kind of leverage the size and the capabilities of our system. And finally, SLICE6 AIR as an adjunct to an existing flight test system or instrumentation system. If the customer has PCM or serial-based configuration, then you can go through this IES 12 product from Telspan. So they've got the switch or the gateway, which will do the conversion, the bit estimation, and the aggregation of our data stream, and output that into a compatible format for the existing hardware. So, those are all just examples of ways you can leverage the capabilities and technologies that we put inside this module. I think what I'm going to do now is set up SLICE6 AIR system, and we'll set it up for streaming Chapter 10 data with our DataPro software. Bear with me here. So what I've got on my bench now, hopefully you guys can see this, is a SLICE6 AIR module hooked up with our interface device cable kit. This is something that we always quote with any new systems. The kit consists of our interface device, which is essentially a breakout box. It has input for power. You can input serial signals, and there's 2 RJ45 ports. There's an extension cable that's tied into a chain module, and the chain module has a 26-pin high-density connector. And we found that it's much easier to work with these high-density connectors. And should the customer want to do some bench testing or test multiple modules, it's much easier to just connect chain modules to one another than it would be to use the MDMs. So as such, this is really a benchtop setup here. I've got one of our angular rate sensors tied in and connected to the SLICE6 AIR as well. So at this point, I will now start our DataPro software. So DataPro gives you the ability to have multiple users and user profiles. So for this demo, I'm just going to use SLICE6 AIR IRIG streaming profile, and we log in. So this profile that I've already set up is broken up into 3 or 4 distinct tabs. We have a tab dedicated for data recorders. This is where you would enter in and add all of your data acquisition systems. So again, I've got 2 that are created in my library. I also have a tab for sensor database. This is where management of your sensor files are going to be handled. So DataPro has the ability to have this be server-based or local machine-based as well. And so selecting on any sensor on the left column here shows on the right side the sensor details. When creating a sensor, you would specify the channel types, manufacturer, you add the serial number. There's things like capacity or range. You can specify the capacity of the sensor. You can then specify different ranges, default ranges for different tests. There's also engineering units and filters. Down below, you've got your calibration information, and you've also got things like your sensitivity levels and sensitivity informations. Test setups are where you would create and configure and build your tests. So test setup uses information from data recorders and our sensor database and pairs the two and then creates a test setup. When setting up SLICE6 AIR for streaming, you want to keep a few things in mind. The first thing is, under system settings, we have what we call test setup defaults. Under defaults, this might seem a little bit overwhelming, but just a couple things to keep in mind would be, you can do things like set DAS to streaming so that, if you're only going to be streaming and you don't want to see any record in place options, you select this. And what that does is it hides a lot of the record to onboard memory functions. Under real-time options, you can select your UDP stream profiles. Again, these are just a few of the examples of the currently supported streaming profiles. For real-time streaming, a couple of things to keep in mind as well is our UDP address. This is programmed automatically in DataPro. And so right here, you have your IP address. This could be set to either multicast or unicast, and we have your port address as well. So going back, let's go ahead and program this SLICE6 AIR module to stream Chapter 10 data. At this point, I can go straight to test setups. Now, while I have already a few that I've made up, I'm going to go ahead and add a new one. We'll go ahead and call this webinar demo. Again, because we set the DAS to streaming enabled, it is now hidden a lot of the features. Just want to unclick this and show you some of the other capabilities that are unlocked when we have that unselected. But for this purpose, we're just going to continue to keep this on DAS streaming. We give it a name. These are some real-time options. We also have options for clock sync as well. So you can set the unit to be either a master or a clock or a slave. There's information for test details as well as diagnostics and ARM checklists. Now that I've got my test setup name, I'm going to go and try to find and see what is connected and add the SLICE module to the test. So in my hardware discovery tab, I do scan all. And so it detects I have SLICE6 AIR serial number 44 connected to the network. Once that's been detected, I then query the module. And you see when the module was queried with DataPro, it responded back with detection of an angular rate sensor connected to one of the channels. And so now the system has detected my data acquisition system. It also gone out and asked what is connected to the module. and it reported back that it has an angular rate sensor connected to channel 3. I can now save this hardware, and all I have to do is run the test. So this is telling me a warning that this file name already exists. I'll go ahead and call this demo 2. Hit run test again. So when running tests, the system will go out. It's going to do its diagnostics to make sure that both the hardware, the data acquisition unit, is properly powered. And it's also going to run and check that the sensors that are connected are operating as expected. So the first check is hardware. Again, it reports back that input voltage is healthy and the status is passed. Because the system supports sensor ID, it can auto-detect what sensor type and which channel is connected to. Okay. Now at this point, I'm going through and I'm running a diagnostics check on that connected sensor. And so the system goes, checks excitation levels, checks the noise levels, checks the initial offset, and it zeroes out any offset. Depending on what the requested range was, it also reports the actual range that's going to be achieved with its automatic gain programming. And at this point, we're ready to go. Next step is really for real time. This part of the setup really is for polarity checks and, to make sure that your sensor is connected to, the right channel and that the polarity is correct. And so I'm just kind of giving it a little wiggle here and we're seeing some response. So I'm happy there. Then I go to ARM. And so SLICE6 AIR is configured to stream via stream on reboot. So essentially, once I hit run, the software tells me the unit can now be disconnected and turned off. Okay. I now exit DataPro. And what I'll do now is I will start up my Chapter 10 display software. Now we can use any number of available software packages out there. We've been working with Telspan's NetView package, and some of our folks here has also been using flighttesting. I've now opened up Telspan's NetView. My system is still turned off. I reboot the system. And upon reboot, the system goes through a series of initial checks and diagnostics. And about 15 seconds later, it's automatically streaming. And at this point, all I need to do is Telspan's NetView, open up a Chapter 10 source, UDP. I've already pre-configured the parameters for my data stream. So I have my network adapter address entered. I've got the broadcast IP address, as well as port entered as well. So once that's been selected, I hit OK. And so to display, I merely go to display. And there we go. So what you just saw was essentially setting up and configuring our SLICE6 AIR module with our Data Pro and rebooting the system. At this point, we're streaming iRig 106 Chapter 10, and this is just another example of the interoperability that we've enabled with the by supporting these kinds of formats. Hopefully that was helpful for everybody. So that really concludes the SLICE6 AIR low SWaP webinar. I hope you found today's webinar useful, informative, but more importantly, kind of gives you a better understanding of the capabilities of SLICE6 AIR and how it can be leveraged to support your test needs. Really welcome the opportunity to continue the conversation. I'll now hand this over to our panelists to answer some questions.
Yeah, thanks, Wee. That was good. So Mike and Locke have been monitoring questions in the background. I believe you should have seen some of the answered questions. Locke has one he'd like to answer live, so I'll pass it over to Locke to answer a question regarding filtering.
Unmute myself. Hello, can anybody hear me?
Yep.
Yes, to answer that, I actually clicked on live, but Darren, yes, we do have plan to actually go forward right now to program to add the digital filtering on top of the analog filtering. So that option is the goal for us right now. We added option in. There's another question that I'd like to also address is the SLICE6 can handle 1553 and airing 429. The answer is yes, it's not with the current device, but it's on our roadmap to design a variance to do that. And the plan is still with the same size mechanically and electronically on the backend interface. Hope that answered. All right, I hand it back to Jim.
Hey, Jim, Mike here. Hi, everybody. Thank you for being here for this webinar today. I just want to throw out, there was obviously a lot of interest in filtering. And one of the things that we've done with the design of this product is we've put in a very, very flexible and programmable analog filter. And what maybe is not immediately apparent is we can support fundamental sampling rates up to roughly 500,000 samples per second. And the analog bandwidth is something that we can adjust very easily with software. And so Locke has been working to meet customer requirements and understand the needs out there, so that because not everybody does things exactly the same way. And so with the great flexibility of sampling rates, hardware filtering, and then digital filtering on top of that, the real question is, what do we need to meet your specs? I see there's a question here saying which types of sensors can we interface with? And the answer is we have both. In SLICE6 AIR, we have a voltage-based input system with a true differential amplifier input with a very wide range of programmable gains. We have an excitation source. So basically, any bridge sensor, any sensor that is, for example, an active sensor that puts out higher level voltages. We have an IEPE or an ICP interface standard on every channel. So if it's any bridge, any voltage source, any IEPE, also we can support thermocouples with a direct connection. We have provisions to support RTDs and other devices. So there's pretty hard to find a sensor in the test realm that we don't interface with.
I see a question for battery options for fully standalone applications. While we currently don't have a standard battery offering, we've identified a number of battery suppliers that kind of meet some of the stringent requirements for this industry. And so we're more than happy to kind of open up discussions with you and understand what your requirements are. Things like, you know, operating temperature environment, as well as record time and operational time. So feel free to contact us directly. There's also another question for, can SLICE6 handle 5053 and AirInc 429 bus traffic? I think this SLICE6 AIR product represents our first kind of entry into the space. And so we definitely see that being a need. And I think that's something that is on our roadmap. Again, just like the battery discussions, you know, feel free to contact us directly. We will understand what your timeline is, and hopefully that kind of aligns with our development schedule. One of the participants is asking whether or not the presentation is going to be available on the support site. Yes, it is. So both our presentation and this recording of the video and the webinar will be available for viewing at a later date. Hopefully you can share it with some of your colleagues.
I also want to add, Mike Beckage here, I'm in charge of the support group and also the help center, our online help center. If you go to dtsweb.com and go to the help center tab on the right side of the screen, it takes you to our online help center. And if you simply type into the search box SLICE6 AIR, you will get a number of documents that give more detail on basically how the hardware is put together, how to make connections, and what types of connections you'd make to your sensors and peripheral systems.
There's a question for plans to support other iRig formats, such as NRZL or Chapter 7. I think, again, you know, I want to defer back to the fact that this is a newly released product. It's still in its infancy. I think everything is on the table at this point. So we would be more than happy to start discussions with you about what your requirements are and how we can help.
So yeah, let me jump in that a little bit. This is Locke. On that question, there was also mentioning of Chapter 7 telemetry. I hope that was what it's for. We do have support for TmNS, Chapter 24 instead. There's very limited on Chapter 7, but like we mentioned, anything on the table. Yeah. From Paulo, the IEEE 1451.4 for test. Yes, we will look into it and we'll get more detailed answer for you. Yeah, follow up. I think Mike has answered the sensors interface with SLICE6 AIR, so that's good. There's a question, does SLICE6 AIR support dynamic test? Yes, we support it. This is a high G rated test. It does support all the tests that you specify here, wind tunnel or flight testing.
That's a good point, Locke. So everybody knows when we put a shock rating or a vibration rating, you know, all those specs have been met through extensive laboratory testing, and in fact, all of these products we do 100% dynamic testing on the products before we ship them. So that's something that we believe in. They're very rugged.
So I believe Mike already answered the sensors interface for SLICE6 AIR. I'll take the next one. What can we use it with more than one bridge with different configuration? Yes, each channel can be configured independently in terms of gain, but in terms of filtering, they will all going through the same filter bandwidth. So in other words, you can configure all 6 different sensors in different 6 channels. They're all going through in with different gain, but they all going through the same rate, same bandwidth. Now, on top of that, once we start adding in the digital filter, we will be able to decimate it to a different rate, but that will be a filter update, not at this current time. Another question, I think this is for Hui. Can we have reference user list for SLICE6 AIR in automotive and aerospace defense with application? So Hui, you want to take that?
Sure. Unfortunately, some of these early customers and early adopters have NDAs in place. I think, again, this is a very new product. I think as the years go on, just like with anything, we'll start seeing more adoption in commercial and industry.
I think another way to say it is we can't share details of customer installations, you know, without permission from the customers, and so we have to treat everybody's uses as confidential. So, but if you know, if you're a sales rep or whatever on the webinar, you can always talk with our sales team and, you know, about your specific needs for reference information.
Question about, does the DAC include data link inside for sending data to the ground? No, that there's no transmitter or encoder in the module. So I think that concludes all the questions that we have.
Yeah, I think so, and we'll leave the line open for any others. We will we'll address those in the next few minutes here, and then anything that goes unanswered, we will compile all the questions and provide detailed answers and send all the questions and answers out to everyone here. So again, thanks, great job. Thanks, Mike and Locke.
There's a question for how is sent streaming if there's no data link. So I think it's the question that's come down to where the system level of the user setup. The DAC SLICE6 AIR is Ethernet based, so it can definitely link to the network, and where you have a telemetry module that send out to ground. But as Hui mentioned, is that it doesn't have a direct data link wirelessly. It's going to be part of your test. All right. So.
Okay, thanks, Locke. And thanks, Mike, for chiming in and answering questions online. Again, thanks, and thanks, everyone, for attending today. We appreciate it. We'll leave this open for a period of time, but at this point, that concludes our webinar for the day. Thank you very much.
Thank you, everyone.
Thanks, everybody. I've got a webinar in 2 weeks.